Hey, welcome back to Math with Patrick and Quill. Today is December 7th, and we're solving problem 341 from the Daily Epsilon calendar. And the answer today should be 7 because that's today's date. So we are given a square. It has equal sides and right angles everywhere. And we have a quarter circle here and another circle inscribed in this square. We're given some information. It looks like half of the side length of the square is 5 plus 3 root 2. I know it's exactly half because these tick marks tell me that we have two parts that are the same length. And from this information, we're supposed to be able to solve for this x. So I think what I'll try to do here is draw more radii of these circles just to kind of get more information on the page. And the first radius I'm going to draw is this one. It's going to be the same radius as this, and so it's the same length as 5 plus 3 root 2. So I'll put 5 plus 3 root 2 right there. And then I'll also draw more radii in this bottom circle. I'll draw one that goes directly down and connects with the square there, as well as one directly across. Both of these are going to be x because they're the same length as this radius. And essentially, I'm just going to use 45, 45, 90 triangles to solve the rest of the problem. A 45, 45, 90 triangle is a special right triangle where it has 45-degree angles in both spots there and then a 90-degree angle here. And let's say we just say that the legs are both one or a length of 1 each. If we do the Pythagorean theorem, that would show us that the hypotenuse is root 2. And this relationship of 1, 1, root 2 extends to basically all other 45, 45, 90 triangles. We would just need to multiply or divide by a scale factor. So for example, if I had a bigger 45, 45, 90 triangle, say I had 5 for both of the legs, then I would have 5 root 2 as the hypotenuse. I'm going to say S is going to be the side of the square. This will be twice the given length. And so we're going to have, say, 10 plus 6 root 2. And that means the diagonal of the big square is going to be root 2 times this amount. So I'll do root 2 times and then 10 plus 6 root 2. Distributing this root 2 to both terms, we will get 10 root 2. And then root 2 times root 2 is 2. 2 times 6 is 12. So the diagonal is the same as this value as well. And finally, let's actually draw this part of the diagonal too. These are, again, 45, 45, 90 triangles. And so we can see in the corner that we have x, x, and then like x root 2 for this last diagonal here. And I think this is enough to set up an equation because we could figure out that the diagonal is the same as 5 plus 3 root 2 plus x root 2 just by adding up the components. And by studying the square as a whole, we also know that this diagonal is 12 plus 10 root 2. And maybe let's collect up the like terms. I could subtract 5 from both sides, so we get 7 here. I could subtract 3 root 2 from both sides, so we get 7 root 2. And then now we're comparing 7 plus 7 root 2 to x plus x root 2. And then here it's pretty clear to see that we can substitute in a 7 for x, and then we get our solution. So x is 7. That is how I would solve it, and we're all done. So thank you for watching, and I'll see you tomorrow. Bye.